Hello. Hello. I'm here to talk about robotic distributed embedded control real-time tracking. I'm Hady Toman, and my supervisor is Dr. Yili Tang, and we're gonna be talking about the problem statement, and we're gonna do a demo at the end. So, project overview. Let's begin with the project overview. So, our project aims to revolutionize how we control and monitor robotic fleets in real-time systems. You designed a distributed system that integrates advanced tracking capabilities with robust mechanisms. And the goal is to offer interface that not only displays real-time location, but also does an interactive map. So problem statements. So challenges in multi-robot coordination. Traditional manual oversight of multiple robots is inefficient and prone to human error. Monitoring each robot's status and location is complex, especially in larger distributed environments. Communication delays or system bottlenecks can lead to unresponsive interfaces and potentially safety hazards. So limitations in existing solutions. Many current platforms focus on either control or tracking, but rarely offer both. Some solutions rely on high bandwidth connections, rendering them ineffective when network resources is constrained. Need for a comprehensive approach. Uh, a secure integrated platform is required to provide um, multiple and robust simultaneously. Operators need initiative interfaces, zoom pan, and geofencing, and real-time alerts like collision detection to manage robotic fleets. The system might be integrated with automatic backups. So motivation and challenges. So there's a growing need for real-time operation and efficiency, limitations in centralized system latency and lack of response, requirement for seamless, secure, and interactive. So problem statement. So difficulty um, and tracking and managing robots, challenges with slow responsiveness in existing web models, need for synchronization of multiple devices and handling. So project objectives. So distribute a real-time tracking system, create an interactive map with zoom, pan, and geofencing, ensure user authentication and data protection, validate through iterative sprints. So system architecture. So we have the client side, which displays the robotic. We have the backend, which data processing, API integration, and session management. So we're using ROS and also Orange Star API, and then automated backups and integrity. So here's the system of architecture. So we have the model right over here, and then to the lower right, we have the service over here, and then we have the UI layer over here, and then we have the database, and then the test packages up there. So established of the frameworks. So here's the sprint one. So established of the frameworks implemented of data and for real-time robotic positioning, secure uh, user login mechanisms, basic robotic visualization. And then for sprint two, building initial success. And then sprint two focus on expanding real-time functionalities, enhance robotic tracking, dynamic movements, and map synchronization across multiple devices. In addition, we have introduced collision alerts, predictive path analysis, integrated external APIs to refine location accuracies. Um, these significant both of the performance and reliability of the system. So testing validations. So testing has been a core of the development process. We are concentrated on key areas such as session management and user um, and real-time accuracy and UI usability. And then the matrix was a sprint velocity and story breakdown. So the challenges, so handling real time with minimum latency, synchronizing data distributed, overcoming technical hurdles, and iterative sprints um, driven by sprint rest perspectives. So here are the development views that I use. So originally I use so I always use GitHub, but originally I use VS Code, and I switched to IntelliJ, Maven, and Ross and Java. That's the process. And now I'm gonna do a quick demo. Do a quick demo of how it works. You just enter username and password. So here's the robotic systems. Here's the different. So we have alpha, beta, uh, gamma robots. Here's the robots managing system. Here's their battery percentage. Here's their location in real time. That little thing that's blinking at the beginning is the predictive prediction. We can also add geofences. We have to select the robot first. Add another geofence here. We can remove the geofence. Remove that geofence too. In case they collide, it will send an alert. We can view the history of each robot first. Zoom in and zoom out. And we have the synchronization here enabled right there. And then we can log out.